This video contains three example problems 1.1, 1.2, 1.3 of chapter 1. The first problem 1.1 is if set A has elements 1, 3, 5, set B has 2 and 3, then subdivision 1 find A cross B and B cross A. Subdivision 2 is A cross B equal to B cross A? If not, why? Subdivision 3 show that n of A cross B equal to n of B cross A equal to n of A into n of B. So first we write the given data set A and set B. Then the actual question contains the first subdivision part is we have to find Cartesian product of A and B, that is A cross B. Then after listing the elements we have to find B cross A, that is Cartesian product of B and A. So just listing these two Cartesian products is the first subdivision answer part. Then second subdivision is we have to check whether A cross B equal to B cross A. To check two sets are equal, we have to find both sets. Then A cross B is contained in B cross A as well as B cross A is contained in A cross B. Checking these 2 points only uh, give the conclusion that they are equal. But if they are not equal, it is enough to prove that just an element from one set is not in an element of second set. That point is enough to prove they are not equal. Later, third subdivision, we have to check number of elements in A cross B and B cross A. They are equal and both are equal to n of A into n of B. That is the third subdivision part. So to derive these answers, again we go to the question. The given sets A and B are taken, and then A cross B is going to be obtained now. The Cartesian product A cross B is actually listed as the set of all ordered pairs whose first element is from A and the second element is from B. It is given in equation number 1. Then B cross A, that is Cartesian product of B and A, is again set of all ordered pairs having elements such that the first element of the ordered pair is from B and second element is from A, which is given as second equation. This listing of A cross B and B cross A is the answer part of question number 1. Just finding A cross B and B cross A. So it's completed. Now, second subdivision, we are moving to the checking part whether they are equal or not. That is, A cross B is equal to B cross A or not. Now we take one element 1 comma 2 in the Cartesian product A cross B. If we check the element uh, exists in B cross A, it is not there. So we can conclude this point is enough to prove this Cartesian products A cross B and B cross A are not equal. If one element in A cross B is not an element of B cross A, then automatically we can give the conclusion that A cross B is not equal to B cross A. Or similarly, we can take that B cross A element 2 comma 1, which is not an element of A cross B. That may be also given as a reason. Just only one element is sufficient to prove A cross B not equal to B cross A. Now move on to the third part. We are going to find the number of elements in A cross B, B cross A, and A and B. A and B has respectively elements 3 and 2. If we multiply the two entries, we get 6. And if we count the number of elements in A cross B, it is 6, as well as B cross A contains 6 elements. So automatically, we get the proof part of third subdivision, that is n of A cross B equal to n of B cross A equal to n of A into n of B. So first 1.1 is completed now. Next we take example 1.2. If A cross B is given as the ordered pairs 3 comma 2, 3 comma 4, 5 comma 2, 5 comma 4, then find A and B. Very simple part A type 1 mark or 2 mark question. Previous case A and B are given, we find A cross B and B cross A. But here, Cartesian product of A and B, that is A cross B, is given. We have to find the sets A and B. We know the first uh, element of each of the ordered pair is from A. So collect all those elements and write it as A. Similarly, the second element of each ordered pair is an element of B. So collecting those elements and enter as B. So we have here A is 3 comma 5 and B is 2 comma 4. Now example 1.3 problem is, let A equal to set of all x belongs to n such that 1 less than x less than 4, and set B is set of all x belongs to whole numbers w such that 0 less than or equal to x less than 2, and C is set of all x belongs to n such that x less than 3. Then verify that subdivision 1 A cross B union C equal to A cross B union A cross C. Subdivision 2 is A cross B intersection C equal to A cross B intersection A cross C. So first we have to write the given sets. Actually the sets are given in set builder form. We have to write in roster form. For that, first we check the conditions. First, A is a natural number with a condition x is lying between 1 and 4. 1 less than, strictly less than, x less than 4. So the elements in A are 2 comma 3. Then come to the second set B. It actually a whole number, and condition is 0 less than or equal to x less than 2. So 0 and 1 are in this set. So set B is 0 comma 1. The third set C is a natural number. X is a natural number such that x less than 3. So below 3 there are two natural numbers. They are 1 comma 2. So after listing all those sets A, B, C, we have to verify these two subdivisions. These subdivisions contains actually union of two sets and intersection of two sets. After finding union and intersection, we make the Cartesian product with A. Then the right side parts are first find the Cartesian products and then making union and intersections. We have to verify finally they are equal. First we write the sets, and then B union C is obtained. B union C means we are going to make the union of the set 0 comma 1 and 1 comma 2. So B union C is now 0 comma 1 comma 2. Then after finding B union C, we make Cartesian product with A. So Cartesian product of A and B union C is given it as equation number 1. It contains first element from A and second element ordered pair, second element from B union C. Those ordered pairs are listed in the equation, which is A cross B union C. Then separately finding A cross B and A cross C, and then make the union, which is given as equation number 2. Verifying 1 and 2, they are equal. Hence, we give the conclusion A cross B union C equal to A cross B union A cross C. So first subdivision part we verify. Now second subdivision part is in the similar way. We have to find the intersection and then find the Cartesian product of A and B intersection C. Then this is LHS. For RHS right hand side we have to find A cross B and A cross C. After finding that, we make the intersection of these two. They are given as equation number 3 and 4, and checking 3 and 4, we get the result, that is A cross B intersection C equal to A cross B intersection A cross C. Thus we verify both results, subdivision 1 and 2, and 1.3 is completed now.